All right, I haven't had Girl Scout cookies in forever, so I apologize with all the examples we do with Girl Scout cookies. Sarah needs to deliver her Girl Scout cookies to her neighbors, Mr. A, Mrs. B, and Ms. C. What is the shortest way she can travel to her neighbors and get back home? Solve using the brute force method. All right, don't mind if I do. So they might give you the weighted graph from the get-go. In this case, they gave us a table, so that means we have to first find the weighted graph. How many vertices do we need? 4, because we need one for where she lives. I'm going to just call that H. We need one for, who we got? Mr. A. Oh, I'm sorry, Mr. A. There we go. Mrs. B, Ms. C. So a complete weighted graph for step 1 with 4 vertices. Well, this is a complete graph of 4 vertices. So again, it's best if you can use your polygons, squares, triangles, pentagons, hexagons, so on, so on. And the weights will be the distances. I hope that these are not in miles. She'll be walking for a while. Let's go with feet. What is the distance from house to Mr. A? 200, so we put that along that edge. House to Mrs. B? 260. Make sure it's obvious on that edge. House to Ms. C? 170. Mr. A to Ms. B, Mrs. B? 90. Mr. A to Ms. C? 140. And lastly, B to C, 180. So to be honest, half that chart is useless because it just repeats. The distance from A to B is the same as B to A. Also, this would have been 10% funnier if it said Mr. F instead of Mr. A. One person. Thank you. It's a joke. Yeah. All right. So that's step 1. Draw the complete weighted graph. It may be given to you. In this case, we had to find it. 2. Make a list of all essential Hamilton circuits. So remember, a Hamilton circuit will start and end in the same place. We want to start and end at home. And pass through all of the vertices once. Who would like to give me an example of a Hamilton circuit for HABC? Yes. An Euler circuit goes through every edge. Hamilton, we don't want to go through every edge, because that means we're revisiting vertices. So the UPS driver doesn't want to drive every street until they get to your house. Do you have one? H, C, B, A, H. Good. That's a Hamilton circuit. Someone else? Say it again. Uh-huh. H, A, C, B, H. Yeah? Mm-hmm. H, B. Notice HBCAH is just this one reversed. So that is a Hamilton circuit. We're not going to write it because it's just a reverse. But that's okay. HABCH. That's the reverse of this one. So here's, HCABH. Good. Let's actually draw pictures for each one. The first one was us going along the outer edge. The second one is an upright hourglass figure. The last one is like a bow tie. When you have 4 vertices, these are your only 3 possible Hamilton circuits. The outer edge square, hourglass, bow tie. Four minus 1 is 3. 3 factorial is 6. 6 divided by 2 is 3. So we have 3 essential Hamilton circuits. Okay. So that's step 2. Step 3, now we write the associated weights. What's the distance from H to C? 170 plus C to B, 180 plus 90 plus, good. What is 170 plus 180 plus 90 plus 200? I got 640, but I might be wrong. I don't know. That's what? That's 350, 550, 640. Everyone else get that? Or is only one person trying? One person is trying. Very good. All right. How about HACBH? What numbers are we adding? HA, AC, 140, which is currently turned down in the room. CB, BH, what'd you get? 780, yep. Last step, HC is 170, CA is 140, AB is 90, and BH, unfortunate, 260, the largest weight. I got 660. Since she wants to find the shortest way she can travel, then for step 4, we would say that Sarah should take from her house, go to C, then B, then A, then back home. She could also go in the other direction too, because that will also be 640. And that's the brute force method. Unfortunately, 4 vertices isn't so bad because we have to make 3 lists. But 5 vertices, we would need to make 12. On your test, you'll have 8 vertices. Good luck.